write an explicit equation if there's an additive rate of change?
All I know is F of n.
You just know f of n. F of n is my what?
Input.
Crap, yeah.
We learned this yesterday.
We went over this yesterday.
We literally talked about this yesterday.
What's your input, Carol?
What's the input?
F of n.
No,
No.
we literally talked about this yesterday.
N.
You
Yeah.
plug into the n and you get out your f of n. I just love how McKay was like so adamant. He was like, "You're wrong, Carol," even though he was wrong yesterday too.
He was trying.
He was. Oh man. Okay, so f of n is an output. When it comes to an explicit equation, and we'll talk about some other formats later, but literally what we're saying is an output equals something, right? Look over at the recursive equation. What is the output that we're starting with in the recursive equation? Look at the recursive equation that you already wrote.
F of n.
That's your starting output?
N minus 1.
Nope.
D.
Oh, it's not that.
Nope.
Plus D.
Nope.
Come on, man.
B.
Oh, yeah.
Remember how this is your starting point, and when you plugged in A, you got out a
B.
B.
Okay.
So what is the starting output?
B.
B.
This is tough.
That's why we're going over it, so you can take some notes. There's my starting output. So notice in this case, f of x would start at what? 7, right? That's that starting output, that b. But what are you doing to that b? Adding what? How much are you adding?
Adding D.
Aren't you adding your common difference?
B plus D equals 4.
Did you just say B plus T?
No, he said B plus
Well,
B.
Oh, okay.
There's your common difference, what you're repeatedly adding by, right? How much are we adding by here?
4.
And here?
4.
And here?
4.
And even into the future, I'm going to keep,
Plus 4.
okay? So I'm adding 4,
Oh, sorry.
but first off, notice how we're repeatedly adding?
So it would be X, or n in that case, n minus 1. And
We haven't gotten to that point yet.
6.
I'm repeatedly adding. Just what is repeated addition?
Multiplication.
Okay, so I'm going to do 4 times something. I don't know what it is yet. Times something. I'm repeatedly adding that common difference. I'm repeatedly adding that 4 in this case. So I'm going to multiply. Now, in this case, yeah, I do have a variable x. Because notice, can the number of times I add by 4 change?
Yes.
Yes. So a variable x. But because I started at the third term, I have to do x.
Minus 3.
Similarly over here, I'm adding d n number of times, but if I started at a, I need to do n minus
Oh, I see how you got through.
a.
Okay, this actually is. Oh, it's pretty good. I have stuff right there.
Oh, I got the explicit.
I'm sorry, I was a little behind trying to understand.
It's okay.
I
Okay.
got the explicit now.
Oh, we good.
Well, one thing I want to point out first is this as well. There's an alternate way to write this equation. There's just multiple alternate ways to write this. I'm going to go into more details about them later. It'll actually help you because you've seen them before.
Yeah.
But there's also a very common thing.
Not one of the things.
Slope.
Notice how there's a slope and there's a point.
Oh.
Slope form.
This is one format for a point slope.
Oh.
Oh, this boy coming back.
Carolyn's like, what are you talking about? We never learned that. Yes, you did.
Oh, we're doing this.
Okay, so that is one format for a point slope, but I just want, the big thing I want you to recognize here is, first off, what's happening between m and the parentheses? Multiplication, which means we're repeatedly adding m. Your slope is your additive rate of change. We need to fundamentally remember that. Okay, we'll come back to that later. So how would we write this for the explicit for a multiplicative rate of change? What you got?
F of m
Okay?
Oh.
equals b plus d to the power of n minus a.
What do y'all think about that?
That's golden.
F of n equals b plus d and
It's golden.
would that not?
So where are you getting this b from?
It's out.
The starting point.
Okay, so what is the starting output?
B.
B. Whatever that starting output is, that's what's going to go right there. What?
B plus r. Not d.
Oh, so it should be b plus r
Yes.
to the n minus a?
Yes.
Okay?
That is a possibility.
Why?
Because it's not a common difference, combination.
Okay, it is a common ratio. Why do you have an exponent on there?
Because you're repeatedly multiplying.
Repeatedly multiplying by what?
N.
Not by n.
Somebody looked up the car.
Oh, someone just saw arms over there.
Repeatedly
No.
multiplying.
You're repeatedly multiplying by r. Have you shown that you're multiplying by r yet?
Times d times r to the power of. Alright, it's going with deflection.
That's the correct
Somebody
equation.
got it. There
You start at your output of b, but what are you doing to b? You're multiplying by r, and we show repeated multiplication with an exponent, so it'd be n minus a. You can also do it as f of x. So, one thing I do want you to remember, we're going to stop here because the bell will catch us in a minute. An explicit equation can be used for both continuous and discrete models. But a recursive can only be used for one of them. Which one can a recursive be used for?
That was, yeah, we said this.
So a recursive equation is only for discrete. Make sure you make that note before you put up your backpack or put up your notebook. So an explicit equation can be used in both models. All right. So this should give you some good formats, by the way. Make sure you mark this out. Don't have that there. You can use the other two.
Okay. Even though that was just wrote down.
Well, I was letting y'all work through it, making sense out of it, instead of me just completely telling you. All right, so we did that. So here's what I want you to do tonight. I want you to figure out, can I erase this, by the way? Do we have all this down?
Yep. Yeah.
I want you to look at this page. I want you to come up with what are the differences between arithmetic sequences and linear functions. So notice arithmetic sequences versus linear functions. So how are these two things different? We already said they both have additive rates of change. So how is one different from the other? How do we show that difference? And I need you to think in terms of models. So discrete versus continuous. And the different representations. Do the same thing for geometric versus exponential. So both arithmetic versus linear and geometric versus exponential. And get those release form signs, please.